So a lot of my research actually focuses more on the issues related to consumer choice and policy, but the work I want to talk about today is mostly this task from the group about what are good decisions to reduce GHG emissions. And so then set up the stage over here in terms of what can constitute the first 80% or the last 20%. I would actually question that a little bit when we look at the numbers. It may be the case that decarbonizing this first part with the light-duty vehicles is not that easy when we look at the trends currently, and definitely the trucks are going to be one big challenge. So the way I will organize the rest of the talk is to address basically four issues. The first one, quickly recapping what's the contribution of transportation globally. Second, what is likely to constitute the first 80% and the last 20%, focusing just on light-duty vehicles and trucks, since Dan already talked a little bit about air and chips. And finally, what are some of the potential solutions? But also highlighting what are some of the key things that, if done today, may get us to a path to make the decarbonization even harder and be dumped on the last 20%. So we need to start thinking about that in terms of dependency. So just in terms of broad numbers about the contribution of transportation to overall GHG emissions, while globally it does account for 1/4 of global GHGs, most of that is road-based, as we can see already from the scheme from Dan. What hasn't been mentioned yet is where is the growth likely to occur for road transportation in particular, and that's mostly going to be in China, other Asian countries, and Latin America. Africa is actually going to be a very tiny little bit of growth in OECD countries, but fairly minor compared to the growth that we'll see in China, Asia, and Latin America overall. And similarly, in terms of the breakdown for the US, that's already been explained, so I'll skip that part. So let's start thinking about, are the 80% really on the 80%, or are they going to be dumped on the last 20%, or at least a portion of that? So light-duty vehicles today, in terms of the electrification, are still less than 0.5%, right? Looking at those numbers, it's going to take a long time to get the full transition to electrified vehicles. And even by 2040, it is expected that there will be at most 15% electrification. Those are small numbers, so just kind of a setback and looking at reality. So what we've done was looking, okay, at today's grid and the slightly decarbonized grid, what are the options for vehicle electrification in the United States? And I'll talk a little bit about a recent piece where we did this, taking into account regionally specific factors. And those regionally specific factors include several things. The electricity mix that you have in the grid definitely plays a very important role. But other types of factors are going to also be quite important, such as the driving patterns and the temperature that you have at the county level. So all of those things may make a technology being better or worse. So we can compare different types of vehicles. A conventional a gasoline vehicle, the Mazda 3, the old friend hybrid Prius without being a plug-in Prius too, the Chevy Volt, and the Nissan Leaf, so all battery electric vehicle. We'll look at what are the overall life cycle emissions of those vehicles at the county level, taking into account all those regional factors that I mentioned. The first and important one is indeed what's the electricity mix that we have currently and in the future. And this is really important to characterize, and we've seen this from other models that will have an equally nice resolution. It's really going to depend on when you charge your car, and so using average emissions factors for the electricity grid is really going to lead you to really off conclusions that don't represent the emissions that you'll have from the sector. So one of the first steps that we've done was to calculate what are the marginal emissions factors that you get from the electricity grid in the United States on an hourly basis in different NERC regions. So really in every single hour by season and location, what is that marginal increment that you have by doing an intervention in the grid? Let that be adding a plug-in hybrid or renewables or so on. So we have that very detailed characterization. The second factor relates to driving patterns, and the driving patterns vary very substantially from county to county, and this is going to be also the case when we look at this problem globally. And so there are two aspects of the driving patterns that are going to make your solution potentially change. The first one is just the driving cycle, the change in velocity over time that you're going to use, and that may make one technology better than another. So conventional vehicles are going to be, the plug-in electric vehicles will have benefits over conventional vehicles in city mode, in stop-and-go conditions, but not necessarily in highway and cruising conditions. And the second one is, and that Dan hinted at, is the distance, really. If you get off a certain range where you can operate the vehicle with an electricity base and you go back to gasoline, that is also going to affect the overall life cycle emissions of those cars. And that varies very, very substantially from county to county, again, in the United States. I also mentioned the temperature, and temperature relates to the overall emissions in two ways. First, the use of HVAC systems in the car, and the fact that that penalty is likely to be larger for some vehicles than others. So for battery electric vehicles, that can increase the overall emissions by 15%. That was some of the numbers found by Jeremy Mihalik and his colleagues. And also the temperature effects associated with the battery efficiency that we started talking about yesterday. And so we use a model from Oregon National Lab and use county-level temperature-specific data to see what that penalty is likely to be. And by the way, that penalty is likely to get worse as things evolve if we don't do anything about climate change, as Chris was mentioning yesterday for the power sector. The same sorts of problems are likely to arise, and they have not been studied yet. Okay, so a little bit about the conclusions when we look first at the grid as it is today. When we compare the conventional vehicles to hybrids or plug-in, any sorts of plug-in, full electric or hybrid electric vehicles, it is the case that the variants with hybrids or some sort of electrification are better in most of the country, but not in all the country, even today. So you have some locations, mainly in the the northern Midwest, where you have a combination of having coal at the margin when you charge the car. At the same time, several of those are rural countries, so you drive more, you have that penalty also for the use of gasoline in hybrid vehicles that comes up. And the cold weather, so we have this penalty on the battery efficiency deterioration, as well as the HVAC. So that makes it such that you're actually better off continuing with your conventional gasoline vehicle in a subset of those countries today. And I'll get in a little bit about how much would you need to decarbonize the grid to actually making that switch. But is that a fair comparison? Perhaps not. So let's forget about conventional vehicle and let's use as our base case just an hybrid vehicle, right? Not a plug-in hybrid, so our old friend, the Toyota Prius. Is that better than plugging in the car and using basically battery electric vehicles or hybrid electric vehicles? Well, it turns out that in some regions in the country, in many regions in the country, you're actually still better off if your goal is to reduce emissions by using the old Prius versus a plug-in for all the reasons that I outlined. So I think this will be the sort of big picture in terms of the analysis, but now your question should be, okay, we're talking about a world where the 80% already happened, so there is already decarbonization of the electricity system. How much would the electricity system need to be decarbonized for us to be better off by transitioning to plug-in electric vehicles of some sort versus using the Prius? Well, it turns out that in the Midwest, we want to decarbonize the electricity system by at least 2/3 before making that switch. Okay, so if we're doing that now, we are not helping the environment, we are not helping climate change, we are actually increasing the emissions. So that's one of the important numbers. So overall, the different attributes, the regional electricity mix, temperature and driving conditions, all are going to impact what's the best solution that you want to tackle. And there is really not one solution that fits all when we look even at the light duty. And I still have a few minutes, so I'll spend just the rest of the time thinking about trucks and the last 20%. We'll hear more about other fuels. The area that, this is actually a joint work with Polly that we focused on with a PhD student, was, okay, we have this overabundant supply of natural gas. Is it a good idea to use natural gas for medium and heavy duty transportation? We also looked at the light duty, and I won't mention that too much. So a couple of things. First, there are some improvements that can be done on trucks today in terms of aerodynamics, low resistance tires, improvement of engine efficiency, and so on. Changes in the AC systems, given that they have powerful GHGs in that. And that gets you the low-hanging fruit, and that gets you maybe something between 10% and 30% reduction on the truck side. So it's non-trivial, and it can help a little bit. But the key problem with the truck portion actually relates back to the policy, also with the technology. But first and foremost, until recently, there were no standards for trucks in the United States. That happened just under the Energy Independence and Security Act. So the first phase of standards that we're looking at for the low-hanging fruit is occurring now between 2014 and 2018. And we're already stuck on the next phase of the standards. They have already been approved, negotiated, and so on. So until 2030, we are in a lock-in situation. Until 2030, in the United States at least, what we can do with trucks is already set by regulation. Okay, so we're looking at the post-2030 strategies here. Not to say that nothing can happen, but given the lag time in those regulations, it's likely that we're looking at after 2030 for any source of other solutions. Okay, let me look back to what we have actually done in terms of analysis. So we looked at different types of pathways for natural gas alone. We didn't look at other fuels. Or better, we'll look at just to compare the overall life cycle emissions from those different natural gas pathways to those of diesel and gasoline for different classes of medium and heavy duty vehicles. We looked at all sorts of pathways that could be pursued using LNG and CNG vehicles, battery electric vehicles powered with natural gas, using natural gas for liquid fuel production as we're discussing, and then using that in conventional vehicles. And I'll just provide the punchline on the findings. I already hinted at that, but basically it's not a tremendously good solution to look at. In particular, for Class 8 tractor trailers and refuse trucks, none of the pathways that we'd looked at could provide emissions reductions. So they would either increase the emissions or maintain the same level of emissions. But for Class 8 transit buses, pickup trucks, and so on, so things that are used in cities, we did find that a transition to battery electric vehicles coupled with natural gas electricity could provide substantial reductions, 30 to 40% reductions. So that could be one strategy to enact and to start thinking about today. Depending again on, this didn't include the temperature effects and all sorts of other things that I mentioned for the light duty, so the numbers could be still shifting quite a little bit. One critical thing that we started discussing is really the methane leakage rate. In the numbers that we use, we're looking at 1 to 2% methane leakage rate. That's still quite uncertain. We actually looked at what would be the sort of break-even methane leakage rate that would be necessary for any of those strategies to be carbon reducing. So a final, very short discussion on potential solutions. Well, it seems that for the light-duty vehicles, indeed, an electrification will be necessary, but with a word of caution that we do need the transition in the electricity sector to materialize. Otherwise, we're getting in a situation that is worse before than, rather than better. The alternative, zero fuel, and just using the same conventional vehicles. But very little attention has been paid to some alternative thinkings, like really considering seriously the modal shift, in particular in cities, and in particular in cities that are growing now and where a large part of the infrastructure is being built. For the medium and heavy duty transportation, a transition to trains and electrifying the trains may be worth some consideration, and see where that is feasible, which countries and regions could actually entail that transition. But other things that have not been analyzed or explored may provide at least a little bit of potential, meaning changes of markets to 3D printing and issues like drone deliveries and so on. There are a couple of papers on that, but if we're looking at the last 20%, they would merit some serious consideration. And finally, I'll end just with this note about the worry of unintended consequences that you may have. If we're looking at large transitions in trucks, these trucks are likely to not disappear or being recycled. They are going to be resold in other countries, and you'll have that penalty of carbon emissions still ongoing for additional decades. So trying to understand how to solve that problem when we get there is going to be quite important. And the second one is the uncertainty on the direction of automation. It can provide some substantial emission savings. One could plausibly also see a very large rebound in terms of emissions due to automation, depending on how the market and the design is. If those vehicles are basically circling back, waiting for someone to pick them up and so on. And I think some neat research on the automation is just emerging now for those last 20%. And I'll end here. Thanks.
Thank you.